I have a conundrum. This equation has no real solutions, but I can solve it. However, this equation has real solutions, but I cannot solve it. So let's solve this equation first, and you know it, we will have to use the Lambert W function, but before that, we will have to take the natural log on both sides, because this way we can put the power to the front. And let me write down that sine x in red, and then we have this ln of sine x. And don't worry, we have to go to a complex world anyway, so don't worry about having a negative inside of the ln. And the right hand side is just ln2. Now, we are going to write the sine x as e to the ln of sine x power, because we have this right here already. And as you can see, this and that match, and we have the e right here, so we can use the Lambert W function. Very nice, and this is still ln2. Okay, let's go ahead and just take the Lambert W function on both sides, right here and also right here. And of course, on the left hand side, we will just get this back, so we get ln of sine x being equal to the Lambert W function of ln2. And then I would like to get rid of the ln. We just do e to the power, e to the power. And now, as we can see, we must have sine x being equal to e to the Lambert W function of ln2. And here is the reason why that we have to go to a complex world. Not just because it's fun, but the reason is because if you enter this on WolframAlpha, you will get approximately 1.5596, which is bigger than 1, which is outside of the range of sine x. But it's okay, we will get complex solution for this. So let's continue. We are going to use the complex definition for the sine x in terms of e to the ix minus e to the negative ix over 2I. And then let's write everything in the exact form. So we'll put this down, and you can see how crazy the answer looks like later on. Okay, this right here is going to be e to the w of ln2. Next, let's multiply everybody by 2I and also e to the ix, because that way we can get rid of that. Okay, take this, multiply by that, the 2I cancel, so take this, multiply by that, we will have e to the ix square, and then take this, multiply by that, it's just minus 1, but let me put it down right here. And when we do this times that, well, it's on the right hand side, let's put that to the left hand side. So we'll get minus, and then we have 2I, and also this, which is e to the w of ln2, and then we have the e to the ix. And of course, now this is just going to be equal to 0. Have a look. What's this? This square, and then we have this, and then this no this. So it's a quadratic equation in this. So we can use the quadratic formula. So we are going to have e to the ix being equal to negative b, which is this. So let's put down negative 2I e to the w of ln2, and then plus or minus and open the square root. We have to do b squared, which is that again. So let's put down negative 2I e to the w of ln2 square, and then minus 4 times a and c. A is 1 and c is negative 1. So let's go and put them down right here, and then all divided by 2 times a, which is 2 times 1. Perfect. On the left hand side, we still have e to the ix. And on the right hand side, of course, let's simplify this a little bit. This is positive 2I e to the w of ln2 plus or minus. And here, check this out. Negative square is positive, but we have an I square which is going to give us negative. So in fact, the coefficient here is negative 4. And here we also have a negative 4. So let's factor out negative 4. But that's inside of the square root. So in fact, that will be a 2I right here. And then of course we have this left, but we have to do that to the second power. So it becomes e, and of course we multiply the power. So we have the 2, and then w of ln2. And of course we took out the negative 4. So we have the negative 1 right here. And all divided by 2. And now, cancel, cancel, cancel. And of course we can also factor out the I. And in the meantime, let's also take the natural log. So this right here becomes ix being equal to, again, we took the natural log, right? So we have the natural log here, and then we have the I being factored in, times just this plus minus that, which is e. Okay, what's next? You can divide both sides by I, but a better way is multiply all this equation by negative I, because that will give us -1, multiplied by negative, that's going to give us positive x. So, ladies and gentlemen, x is going to be negative I, so I'll put this down in blue, negative I. But the thing is that, you see, here we have ln of this times that. So we're going to break them apart. So it becomes negative I times, here we will have, this is ln I, we are going to take care of that in a second. And then we are going to add ln of the rest, which is going to be just all that. So that. And then close that. Close that. I did close the parentheses, okay? Whew. Okay, so what is ln I? Well, if you look at the complex plane, I is right here, the angle is pi over 2, and then the radius, the distance is 1. So this right here is the same as e to the pi over 2 I. This will give us I. If you put this right here, e and ln will cancel, so in fact this right here is just pi over 2. So pi over 2, and of course we have the I. Okay? Alright, and then of course just finally fix everything. X is going to be I times I is -1, but I will have another negative, so it's positive. So we have positive pi over 2. And then do this times that. So we will have a minus I, and then all that stuff again. Close parentheses. Whew. Yep. But that's not it yet. This is not it yet. Even though you can produce a lot of solutions based on the branch of W, but X came from sine right here, right? So we will have to do what? The period of sine is 2 pi. We'll just have to keep adding it. So I will just say we have all this stuff, and then we have to add 2n pi, where n is an integer. But anyway, this right here is indeed the solution to that equation. I told you it's solvable in the complex world, which is pretty crazy. And yeah, this is like the super version of sine x is equal to 2, right? So now let's take a look at the equation. Sine x to the cosine x power is equal to 2. And you might be wondering, how is this possible to have real solutions? Because we know the absolute value of sine x in the real world, it's always going to be less than or equal to 1. So it is for cosine x. And now you see, we are saying that the absolute value of this is at most 1, raised to the absolute value of this is at most 1, and somehow we can legitimately end up with 2. How's that possible? Well, don't worry, let me explain. This is what I was thinking when I was coming up with this equation. Let me show you guys the unit circle. It helps. Keep in mind, everything is in the real world now. With that said, we need to have the base to be positive. And for sine x to be positive, that means we have to be in the first and also the second quadrant. So now keep in mind, the base is positive and it's going to be less than or equal to 1. So let me just put this down. We want to have 0 less than sine x and then less than 1. How is this possible that we take this raised to a power and we end up with 2? Well, it is possible if the power here is negative. And in fact, cosine x will be negative if we are in the second quadrant. So perfect. And in fact, if you would like, go ahead and just graph the equation sine x to the cosine x power. You will see the graph looks something like this. So this is y equals sine x to the cosine x power. And of course, it crosses 2 right here. And it has infinitely many of these curves, but I'm not going to graph them all. But now, I will have to tell you guys the sad news. I don't know how to find a real solution for this. I tried. I really did. Let me show you. Right here, sine x for the base. We know cosine can be written as plus or minus square root of 1 minus sine square x. And we say that's equal to 2. And I tried what we did earlier. I took the natural log on both sides, so I can bring the dash thing in the front and all that stuff. But it's getting too crazy, you know? This is just like an unfortunate that this equation is actually so nice, especially you have real students, but I don't know how to solve it. If you guys know, please let me know.